We're going to talk about the Diels-Alder 4+2 cycloaddition reaction, most commonly just referred to as the Diels-Alder reaction. This is an extremely useful reaction in that it allows us to make six-membered rings. In fact, this reaction is so important that the developers were awarded the 1950 Nobel Prize in Chemistry for their work. Let's take a look at how this reaction takes place. So there's two components to a Diels-Alder reaction. The first is a conjugated diene. And I'm drawing it in a particular conformation, and you'll see why that is as we do the reaction. So we have our diene. We have a second molecule, which is a pi bond. I'm going to keep it really simple and just do ethylene. But this component is called the dienophile. And that term basically means the phile means it's a diene lover. So dienophiles love to react with dienes. If we react these two things together, and let me just highlight the diene in green and the dienophile in blue. So these undergo a cycloaddition reaction where the two components essentially align and form a six-membered ring. In terms of electron movement, if we want to show that, we can start at one of the double bonds. So let's start at the dienophile and put our pencil down on the pi bond. I'll draw an arrow to here. That pushes these pi bond electrons to here. And these pi electrons come and form a bond here. So what we end up with is a six-membered ring. Here are the 4 carbons from the diene. Here are the 2 carbons from the dienophile. If we track our electron movement, we end up with a new pi bond right here. And I'll draw the new sigma bonds in red. So there's our product, which is cyclohexene. This is the core of everything we're going to talk about in this section. So you'll find we're going to make this more complicated by adding some groups onto the dienophile, adding some groups onto the diene. We're going to look at how those groups affect the reaction rate and then potential stereochemistry in the product. But at its heart, you always form this cyclohexene core. Let's look a little bit at the terminology. So the title of this is a 4+2 cycloaddition. So what does that mean? Four plus 2 means that we have 4 atoms joining 2 atoms. The 4 atoms come from the diene, the 2 atoms come from the dienophile. This is referred to as a cycloaddition reaction. And a cycloaddition reaction is a paracyclic reaction. And what that means is it's a concerted reaction with a cyclic transition state. Concerted, you may be familiar with this from Organic 1. the SN2 reaction is a concerted reaction. And all that means is that there's no intermediate. So with that, all we do, if we look at the reaction coordinate diagram, we're going to go from the starting materials over a transition state, and then we get to the products. There's no intermediates along the reaction pathway. So that's a concerted reaction. Because the concerted reaction has a cyclic transition state, that's why it's called a paracyclic reaction.